So we're out on the water again, 2 sea tankers. Let's hope we don't get wet. So the first thing we need to do is to find the distance of the tanker A at 2 a.m. So at 2 a.m. T equals 2. So we put T equals 2 into the X and Y coordinates of A, and we get the value of X and Y for tanker A as 46 kilometers and 28 kilometers. So to find the distance from the port, we simply use Pythagoras. So the distance of A from the port is around about 54 kilometers. So second part, part B, we need to find the distance between the two tankers at 6 a.m. So to do that, we need to know where each of the tankers is at 6 a.m. So we put 6 into the positions of A and B now. So we get the position of A and the position of B respectively. And then we use Pythagoras on the difference between the coordinates of A and B. So that gives us 62.3 kilometers. Part C is a bit different because we're now looking for the closest distance between the two tankers. So if we say that the distance between A and B at some time t is d, that's the distance between the two at any given time, then d is going to be the square root of the x coordinate squared plus the y coordinate squared. So where does this come from? Well, I'm looking at the difference between A and B, and the difference is in the x coordinates is 8t plus 10 minus 50 minus 2t. That's the x difference, and I'm squaring it. And then the difference in the y coordinates is 5 plus 2t minus 4 plus 12t. So this expression is if A is here and B is here, then the distance between them is the hypotenuse of this triangle here, the square, the right-angled triangle. Hope you are happy with that. So simplifying that and further. So this is an expression for the distance between the two tankers at any given time. But we're trying to find the closest distance. So we're trying to find when is the value of t that gives the minimum value of d. So the minimum value of d will occur when the contents of the square root are at a minimum value. So we're trying to find the minimum value of this function. Well, like a lot of other minimum or maximum problems, this involves differentiating and making the differential equal to 0. Well, the differential of that is minus 820 plus 400t, and that has to be equal to 0. That gives a value of t of 0.25, and then when we put that value of t back into this expression, we get d min, the minimum value of d, is 27.6 kilometers. So no danger of them colliding, thankfully.